Good afternoon, AP Stats friends. This is my feeble attempt to try to teach you this next lesson on proportions. Check out this app that I'm using. I was able to take a picture of our handout, so it's a little bit nicer. At least I don't have to refer to the page over and over again and make you have to look back and forth, so you can at least see this. It's like a little document camera. So we're going to give this a whirl, so just bear with me, okay? I'll do my best to make it as well written as possible. It's a little tight, so we'll see what happens. Our topic's called a two-proportion z-test. Okay, so we're working with two proportions and comparing them instead of just one proportion. So a couple of things as I'm going through it, I'll try to on the side tell you what's up. So here we go. Let's just use this example to get us going. So we've got some adverse symptoms when you take over-the-counter pain relief meds. And the two medicines that they're comparing are acetaminophen and ibuprofen. And so what's happening is they're giving us two completely different samples. Two total different samples. Key thing I'm looking at is it's telling me two different sample sizes. So I'm going to kind of scratch through the two sample sizes. So I've got 650 who took acetaminophen, and then 347 took ibuprofen. And so we're just going to look at the adverse symptoms and see if indeed that they differ. Okay, that's going to come into play too when I set up my ho and ha. All right, so the first thing I like this page that we start off with is because it walks us through everything. State, plan, do, conclude. So this first number one is my stating. So like the last test, we're going to identify the parameter, the population parameter. But wait a minute, I've got two populations. So I'm going to use a little subscript to tell the difference. So I'm just going to let the first population parameter be the acetaminophen group. So that's the percent of people taking acetaminophen. I'm going to kind of abbreviate if that's okay, because this is a little squished. And then the second population parameter, P2, is the percent of people taking ibuprofen. Okay. Now, the procedure that we're going to be using for this test is a two-prop z-test. And that's the way the lingo is in the calculator, but it's two-proportion z-test. And yes, I'll talk you through how to do it also on the calculator. But just kind of letting you see how I'm going to set up the ho and ha. Every null will look like this. We're claiming that there is absolutely no difference, or they're claiming there's no difference in the adverse symptoms between the two proportions. So I'm going to say P1 is equal to P2. Now, FYI, some textbooks do this. P1 minus P2 equals 0. Well, just solving, kind of using some algebra, if I took that little guy over here, then it would be P1 equals P2. I'm going to try to stick to what our textbook does and the way I've taught it for years. But if you see something like this here, don't freak out. Just convert it to what you're used to seeing. Now, the alternative is what they're asking us to see. So they just want to know, is there evidence that the two pain relievers differ? So anytime you see the word differ, then you know you're going to have what's called a two-tailed test. Okay, and this is not equal to. So when I'm not equal to, we're assuming I can be greater than or less than, okay? So however you want to put it, but we're going to say not equal to. All right? And so that is just the state part. And then we need to get into the conditions. Well, again, our conditions don't change, but slightly, okay? So, simple random sample. So I got to go up here in the stem of the question, in the prompt, and see if they ever said simple random sample. Well, they said they were randomly assigned, but they didn't take a simple random sample. So I'm going to kind of say doesn't say. But I am going to kind of refer to that it was random assignment. And so kind of proceed with caution, if you will. Now, when I address the population at least 10 times sample size, guys, I have 2 places I need to address this. Okay, I need to address the acetaminophen, and I also need to address the ibuprofen. So I'm going to assume that at least 6,500 people who take acetaminophen are in existence. Now I want to abbreviate. And at least 3,470 people in existence who take ibuprofen. Okay, so listen to me. I can't get it all written out, but just listen to me. Okay, now we're assuming independence. So those that take acetaminophen and those that take ibuprofen have no influence on each other. But this is where we get into a little bit of writing, okay? And so I'm going to jump over to a blank screen and get you into the normality check, okay? So give me a chance to get there. So a little bit better room here. So this is the last condition I need to check. So normality. Now, with this type of test, I run into a brand new P. Okay, and so I'm going to label him as P hat combined. And you're going, what? What does that mean? Okay, well, don't freak out. Here we go. I'm going to combine the 2 proportions. So I'm going to label him P hat subscript C. And so what I'm going to do is I'm going to look at my stem and my question. And on the top is the number of people who experienced adverse symptoms who took acetaminophen, and I'm going to add it to the number of people who had experienced adverse symptoms who took ibuprofen. So in other words, it's the number of successes. I say that with quotation marks because it's sad that you get adverse symptoms with taking ibuprofen and acetaminophen, but that's our focus. And then the bottom denominator is just the 2 sample sizes added together. So 650 plus 347. And I'm going to get what we call a combined P hat. Okay, so that value is 0.0933. Okay, so not hard to figure out, but you need to do that in order to do this normality check. And so, guys, the rules don't change. We're still doing N times P, but wait a minute. Since I have 2 of these populations I'm fooling with, I'm going to end up using this P hat combined. So I'm going to check, is it greater than or equal to, and then we're going to kind of change our movement, and we're going to do it, instead of doing 10, I'm going to split 10 in half, because I have two sample sizes. So N1 times p hat combined greater or equal to 5. N1 times 1 minus p hat combined greater than or equal to 5. So I'm going to go ahead and give you those numbers. That way you can keep them straight. So here's the first. So I'm taking 650, the acetaminophen group, and I'm going to take it times 0.0933. And I'm just going to make sure they're greater than or equal to 5. And then 650 times 1 minus 0.0933, greater or equal to 5. So that's the acetaminophen group. But I also have to do the ibuprofen group. Okay, so I have to do the second sample times p hat combined greater or equal to 5. Second sample times 1 minus p hat combined greater or equal to 5. You're thinking, man, this is a lot of writing, a lot of stuff to keep straight. After you do a few, you do keep it straight. So here I've got to change the sample size to 347. So 0.0933 and 347, 1 minus 0.0933. And all four of those are going to check out. Okay, so 9% of 347 is definitely greater than 5. And 9% of 650 is definitely greater than 5. So all of those are going to be good, so we're going to assume normality. Okay? And so, so far so good with the planning stage. Now I'm going to jump back, and I'm going to start talking about the test statistic. Okay, so here we go. So it says calculate the test statistic and the p-value, okay? So just some side work. I do need to calculate the acetaminophen sample proportion. So 44 out of the 650 people had adverse symptoms, so that's going to give me 0.0677. And then I want to do the ibuprofen group. So there were 49 out of 347. And that was 0.1412. I'm still going to do a z-score. It's just that my formula has changed a little bit. Okay, now this formula is on your formula sheet, and I may snap a picture and do some notes beside the formula sheet that you've got in hand, that blue thing that I've handed out to you. So here's how our z-score is going to work. We don't have a p. So in the numerator, we're actually going to take the difference between sample 1, the p hat. Oh, I probably wrote it too. Let me move this down just a little bit. It's going to mess me up a little bit. All right. So 0.0677 minus 0.1412. So this is p hat 1. And here's p hat 2. And so I'm just going to take the difference between them. Now, this is what's changed our denominator. We are now taking what we call standard deviations, okay? And so I need to figure out a good way to do this. And so here we go. the first number was p hat combined. And so remember us using and calculating p hat combined 0.0933. So that little guy here is p hat combined. Okay, and then I'm going to go 1 minus 0.0933. And then I'm going to multiply that by this proportion, 1 over 650, which is the first sample size, and 1 over 347, which is the second sample size. Okay? So, underneath in the denominator, we're using p hat combined as our percent. Okay? And so, a little different. Again, I'll show you where it is on your formula sheet, so just bear with me. But you can do all of this in your calculator. So I'm going to 2 prop z test. So if you follow along with me, you're going to choose it. It's number 6. And it's got x1 and then n1. Well, x1 was 44. That's how many people had adverse symptoms who took acetaminophen. And then n1 was your sample size. And so you do the same thing with x2, n2. And we're choosing the not equal to sign to help us make our decision. And we end up getting a z-score of negative 3.8. Okay, and then while I have it, I'm going to go my p-value right below it is, and pay attention, it says 1.4345 and then e to the negative 4. You will never, ever, ever have a p-value greater than 1. It's a percent. So when you see 1 point, don't think it's above 100%. It's not that. So this is really 0.00001. I think I went 1, 2 extra zeros. Yeah. Let me redo that. Here we go. 0.000. There you go, Miss Stevens. 1, 4. Okay. And then while I got you, while I have you, is that p-value less than an alpha level of 0.05? And heck yeah. And so you know that your difference, it is significant. Okay, so we do get to reject. Okay, and I'll get into all the words and stuff here in a second. Okay, so that's the gist of it. Don't forget your stinking sketch. Okay, and so I'm just coming down here. Now again, I'm using my whole screen to get all of this written. So I'm still up here calculating the test statistic, and I'm sort of implying what kind of conclusion, but I'm going to give you the words here in a second of how to say it. So on this one, I'm going to end up doing negative 3.8 and positive 3.8. Ms. Stevens, why is it negative? Well, it's because I took P1 minus P2. The proportion in P1, the first sample in acetaminophen, was actually smaller than the proportion in ibuprofen. Now, can you reverse that? Can you make P1 be ibuprofen and P2 be acetaminophen? Yeah, you can. It's just you need to let the reader know what you're doing. And that's why it's important in the state to get that clear. All right? And so I'm going to finish up my little drawing. Okay? And then I'm going to say, what conclusion can you draw? So I'm going to end up erasing this real quick. Hopefully you can pause if you have to copy all the notes. But I want to be able to write the conclusion the way we say it, okay? So here it goes quickly. Okay, and so I'm in here to what conclusion can you draw? So this is the writing part. Well, because the p-value was less than alpha, we get to reject. Okay, and so here we go. So we have sufficient evidence to reject the null and claim or state, however you want to say it. And here's our context, that the percent of adverse symptoms in acetaminophen and ibuprofen are different. All right, and so everybody kind of okay with that? So the key word, that the difference, okay? And so as we get into other tests, you might say greater than, you might say less than. So this piece right here that I'm underlining or highlighting here is the alternative hypothesis. That's what I'm claiming. Okay, I'm not saying it's true, I'm just rejecting and stating that we do have enough evidence to indeed say they are different. Okay? All right, the last part is constructing a confidence interval. All right, and so when I do a confidence interval, most of the stuff is the same, but again, I'm doing a state, so make sure you let the reader know. So we're doing a 90% confidence interval for the true, now keyword here, difference in adverse symptoms. Okay. The second thing I got to do is, like above, like before, all my conditions are met. But this time, with normality, I gotta check it. So my normality check is a little different. Okay, so I'm gonna slide over to a nice clean screen and do a normality check for a confidence interval. Now these are for two proportions. Okay, well, remember in the test I used p-hat combined. But with the confidence intervals, we go back and use the original p-hat 1, p-hat 2. So I'm doing n1 times p-hat 1 greater than or equal to 5, n1 1 minus p-hat 1 greater than or equal to 5. So let me get those taken care of for you. So 650. Now p-hat 1, 0.0677. And then 650, 1 minus 0.0677. All right. So 6.7% of 650 definitely greater than or equal to 5. And the second one's greater than or equal to 5. And then your second part, your second sample, n2 times p-hat 2 into 1 minus p-hat 2 greater than or equal to 5, sorry. Okay, so 347. And remember p-hat 2, 0.1412. And 347, 1 minus 0.1412. So both of those are going to be fine. Assume normality. All right. The procedure that we're using is called a two proportion Z interval. So this is still part of the stating and planning stage, okay? So this is the procedure, and you need to let the reader know what you're doing, okay? Then flipping back, we're actually going to kind of work it. So let me just stick to a clean screen. I'm not going to flip back to the question itself. So what changes? Well, remember we always used a p hat. Well, I've got two of them. P hat 1. And just like the test, sort of, I'm going to take the difference. Plus or minus Z critical. Now, the standard error, again, in your formula sheet, they give it to you. And we're not using p hat combined at all in a confidence interval. So this is p hat 1. Get it to go. 1 minus p hat 1 all over n1. P hat 2, 1 minus p hat 2 all over n2. All right, so the reader just wants the numbers. Let the calculator do it for you. Okay? And so here we go. So stick your numbers in there. 0.0677 minus 0.1412 plus or minus. I'm looking up Z critical on my table. 1.645. And then these numbers here are the numbers I'm going to use under the radical. Okay, they're the same. So 0.0677, 1 minus 0.0677 all over 650. And then 0.1412, and then 1 minus, I'm going to run out of room, but you get it, over 347. Okay, so you're going to go to your calculator, and you're going to get two proportion Z interval. Okay, where is it? When you go to your calculator, it's letter B. Okay, and the cool part is it already has your X1, N1, X2, N2. You just have to let the calculator know what level you're using. So 0.9, calculate, and it'll give you this result, negative 0.1083, negative 0.0388. Why is it negative? Again, it's the order that I use the two proportions, proportion 1 minus proportion 2. All right, and then we finally get a conclusion. We are 90% confident that between, now you can drop the negatives if you want to, because why was it negative? I just told you. 3.9% and 10.83% more people suffer adverse symptoms from, now, who dominated the sign? Well, it was ibuprofen dominating the sign because he caused my results to be negative. So, suffered adverse symptoms from ibuprofen than from acetaminophen. Now, you can also say we are 90% confident that the true mean difference between people who take acetaminophen and people who take ibuprofen, their percent of adverse symptoms will fall between, and you can just say negative 10.83% to negative 3.88%. You can say it verbatim like that. Okay, and so as we get into these, I'll show you different options of how to say this. Okay, so I'm going to do a different video for the second question, okay? So hopefully I've not overwhelmed you, okay? So hang in there.